Hi, this is Chris Armstrong with RIGOL Technologies. Today we're going to expand on our IoT power measurements with an RF test. We're going to test 3 different power levels, transmitting out of our Bluetooth low energy antenna set. First, we're going to look at our IoT board, with the RF components active, but no signal being transmitted. On the spectrum analyzer, we can see that there's no peak. And now we're powering it with the power supply over here. And we can see that the current on the DMM is showing about 50 milliamps. And on the oscilloscope, we're showing about 58 milliamps. And the difference really is these current pulses that are happening where the IoT uses the power in a non-DC fashion. We're going to save a reference for these measurements so we can compare them to the measurement in the next step. Here in our second test, we've adjusted the output of the IoT board. We now see a peak at minus 40 dBm on the spectrum analyzer, and we see a little more current being consumed. The DMM is now reading 54 milliamps, and on the scope we can see up to 64 to 65 milliamps. In the final test, we'll do one more at a much higher output level and see what that looks like. And now in this test, all we've changed is the IoT board is now transmitting at full power at a 4 dBm signal. We see the blue trace on the spectrum analyzer in reference to the others from the previous test. And now we see the DMM measuring about 65 milliamps and the scope measuring up at about 72. So what this shows overall is that a majority of the power used by this particular IoT platform is in just charging the RF components for the basic test. Actually outputting more signal uses relatively smaller amounts of current. These are important realizations as you develop your IoT platform into a full-fledged device. In this test, we are comparing current measurements in different IoT radio configurations using RIGOL's 5.5-digit bench DMM and our 4000 series oscilloscope with a current probe. With today's IoT devices, it is important to note that high-speed current capture, like the oscilloscopes, is important to getting accurate power readings. This is due to how the IoT board draws its power from the battery or supply in a pulsed fashion. You can reach us at www.rigolna.com for more information.